So in this video, as part of the top interview 150, I'm doing remove duplicates from sorted array. Given an integer array nums sorted in non-decreasing order, remove the duplicates in place such that each unique element only appears once. Okay, the relative order of the elements should be kept the same. Okay. Consider the number of unique elements in nums to be k. After removing duplicates, return the number of unique elements k. Okay. The first k elements of nums should contain the unique numbers in sorted order. The remaining elements beyond index k minus 1 can be ignored. So basically, we just okay. So okay. So one strategy is simply that if whenever we find a duplicate, we simply give that duplicate a different value, and then finally we can just give that duplicate a different value. So give it like a very distinct value. Let's say like the largest element in the largest element possible, so it'll automatically be at the end, and then we can sort the array again. But and then that's a pretty simple solution, because it doesn't matter what you leave beyond the return k. But I'm not sure if that is the most efficient way of doing the job. Another thing I can do is I can make a new temporary array, and then copy over the original array without duplicates. And then since I'm doing it in place, I simply have to copy like that many elements back, which would mean that at most it's going to be O of 2n. So O of n, or yeah, I don't think there will be. I think that will be a more efficient way of doing it than having to sort the whole array again. Okay, so let's do it like this. Okay, so int temp equals new int nums dot length temp at 0 equals nums at 0, just because wait, let me look here for a second. Okay, yeah, temp at 0 equals nums at 0, just because the first one will always be in there. That's not going to be a duplicate. And then now we can say for int I equals 1 is smaller than nums dot length I plus plus. So we actually need int counter. We need a counter to keep count of variables that we're to keep count of how we're updating and moving the temp array. So we will go ahead and do that. So we have our counter here. Now let's say if nums at I does not equals nums at I minus 1, then we can insert it into our new array. So we'll now say temp at I equals nums at I, and then we will say counter plus plus, we'll increment our counter. So this is saying that if if not duplicate. Basically, if each element is not equal to element before it, and since we're sorted, that means it's duplicate. And then let's say the element after this one is the same as this one, we will add it this time, but then on the next iteration it will not pass this condition because it will be the same as the one before it, so we wouldn't add it again. And then we increment the counter. Actually, it's temp at counter. So we'll just set this to 1 actually. Temp at counter and then counter plus plus, because otherwise we will increment. Okay. Sounds good. I think we are good. What is the return here? Return the number of unique elements k, which will just be equal to counter. Okay, now actually I need to copy it back. So for int I equals 0, I is smaller than counter, I plus plus. Now we just need to copy this temporary array back into my original array, but only for the amount by which we actually remove the duplicates for, not the entire size of the array. So now we do nums at I equals temp at I, and now we can return counter. So let's give it a run. Just a small spelling error there. Nums, yep. Okay, let's see if it works for everything. Okay, perfect. And the runtime complexity is pretty good as well. So that's it.